as you transition from general chemistry to organic chemistry, I'd like to talk about how we draw things in organic. In general chemistry, you drew everything using Lewis structures. And Lewis structures are great because it shows you the two-dimensional conformation of what you're working with. In organic, however, we don't necessarily do this all the time. So we do what's called bond line drawings, and we're going to use an example of C5H10, which is pentane. So we're just going to draw the Lewis structure, the Lewis structure for pentane, 5 carbons, and we're just going to place those hydrogens around those carbons. So after you get done doing that, and we want one more, and now we're done. So it took me however many seconds that just was to draw pentane. And this is just 5 carbon atoms, and I should say this is C5H12, not 10. So yeah, make that change, you guys. I'll even black that out right there and say C5H12. Right? So in organic chemistry, we don't use all these Lewis structures because it would get really tedious to draw out carbon atoms and bond all the hydrogens to them every single time. So we use instead what we call bond line drawings. So in bond line drawings, every terminal point and every intersecting point represents a carbon. So here's a carbon, here, and here. So we have 1, 2, 3, 4, 5 carbons. And then we only show bonds to carbons or things we call heteroatoms. Heteroatoms are basically not carbon and not hydrogen. So if there's an oxygen, you're going to show the carbon bonded to the oxygen, whether that's a single bond or a double bond, what have you. Okay, if it's a nitrogen, you're going to show it. If it's a fluorine, you're going to show it. If it's a hydrogen, you're going to assume that carbon always has 4 bonds, right? So we're going to draw in, right? We can draw in all of our hydrogens, right? So carbon is in group 14 of the periodic table. It means it makes 4 bonds. So remember the time that it took me to draw this guy. Now I'm going to draw pentane using a bond line structure. 1, 2, 3, 4, 5. Done. So that's a lot faster. And again, remember, so I have this little blip down here, and it's basically just re-saying what I just said. So we only show bonds to carbon and heteroatoms. So we do not show carbon-hydrogen bonds unless there is a positive or negative charge on a carbon. You assume that if there is not 4 bonds shown, that the other bonds are to hydrogens. So 2 more examples that I'd like to go through before concluding this video were hexane, and this is just the bond line structure, and cyclohexane. So let's draw hexane first, right? So remember that's 6 carbons, so I want 1, 2, 3, 4, 5, 6. Remember that there's going to be implied hydrogens, right? So there will be 3 hydrogens here, 2 here, 2 here, 2 here, 2 here, and 3 here. 3 plus 3 is 6. Plus 2 is 8, plus 2 is 10, plus 2 is 12, plus 2 is 14, C8H14. We're good. Thank goodness I didn't mess up the formula this time. And then for B, okay, for cyclohexane, we're going to take these 6 carbons. There's still going to be 6 carbons, but instead of having it a straight line, they're just going to form a ring. So you're going to imagine that this carbon and this carbon have a bond. Now we draw that a lot more elegantly, so we just draw a 6-membered ring, or a hexagon. And remember, so there would be 2 hydrogens at every intersection, obviously no terminal, but that's still 6 carbons, and believe me, you're going to get really good at drawing hexagons in organic chemistry, right? But then there's 2, 4, 6, 8, 10, 12 hydrogens. So the formula here is C6H12 and C6H14 for regular hexane. I hope this cleared up bond line drawings, and we'll see you in the next video on resonance.